Okay. Good to see you all. Thank you for joining and thank you for postponing your lunch or taking an early lunch. Please do step in. I'm just starting, so happy to increase the crowd a little bit. But I suggest we get started, and I'm sure, I hope there will be more people joining. So welcome, my name is Maarten Berkhout. I'm one of the co-founders of SeaQurrent, and with SeaQurrent we develop an underwater kite to harness the flows of the seas and oceans. So tidal energy is our business. And well, I will elaborate in my presentation, of course, why we are doing this and how the kite works and why a kite, in our view, is a logical complement to some of the tidal turbines that you find also on this exhibition floor. Yes, that works also. So I'll shortly introduce our system, then focus a little bit on France, and then elaborate a little bit on what we see as our road to the market in France as well as elsewhere. Of course, we are doing this because of the energy transition. I guess we will not dwell too long on CO2 emissions and climate change abatement. But I think what's interesting to note is that, in my view, we're entering sort of the second phase of the energy transition. The first phase has been spearheaded by wind and solar, and these sources continue. But we see an increasing number of new challenges in the energy transition that we have to account for and that require additional solutions. Grid congestion is one of these items. We see negative prices. I mean, as a Dutch, I can say we're world champion solar panels, so the number of solar panels per head of the population in the Netherlands is the highest. Not sure whether that's directly correlated to the amount of sun we're getting, but that's a different story. But it starts showing problems, it starts showing negative prices and challenges, and so increasingly additional solutions are sought. Of course, also to a large extent driven by geopolitical events in Eastern Europe, and reliability, security of energy supply, if you ask me, split in three main steps is increasingly an important element. And these steps are: let's use the local energy, the energy sources to produce energy, but the second step also, let's use European-made technology, and the third step is let's avoid using critical raw materials from elsewhere. So we're certain we can repeat this and we keep our access to energy. Need to click the right button. So tidal energy is a huge potential, and with our TidalKite we even enlarge it. So the TidalKite market, the tidal market basically is doubled by the TidalKite technology, in our view. We find this market in the Netherlands, our home market. Not a huge potential, but significant from a regional perspective, and some of the regions are very supportive. In particular, in the north of the Netherlands, the Waddenzee area, that is a bird sanctuary and a UNESCO World Heritage, where wind turbines are not the right solution. And tidal is very much embraced. Beyond that, in Europe, we find the big markets in the UK, Ireland and France. And of course, worldwide, everywhere where land masses basically constrict water flows, that is where these water flows accelerate, and that's where you find the potential to exploit this resource. The tidal resource, that's one. So water moving in two directions, and then we've got the ocean currents. So that's water moving in one direction, often at a lower velocity, and that's exactly also what we focus on with the TidalKite system. I'm not doing this alone. I'm here together with my colleague Julia, so if you have any questions, you can also ask her. And a team of more than 20 people by now, most of which are currently at sea testing our device. So our TidalKite comprises a kite. I also here have a small scale model that you can see with a lot of wings. So these wings capture the flow. Of course, it's positioned downstream, so the flow is coming from you towards me. The wings capture the flow and make the kite move perpendicular to the flow direction. This has several benefits. So we can cover a much larger area, certainly in shallow areas. When you envisage that water is, for instance, 20 meters deep and you would harness the flow with tidal turbines, you can imagine that the blade length is limited because of the depth. And with the kite, we can sweep from left to right. So if we would put a frame at the seabed where the water is flowing through, we can cover this frame, the area where the water is flowing through, by sweeping with the kite from left to right, returning at a different depth, And then also we're harnessing energy in the third dimension because the wings are placed behind each other. We don't only operate in one plane like turbines do, but have multiple planes behind each other where we extract energy from. Maybe a bit complex, a bit technical, but it allows us to harvest much more energy from the same site with a single device. So that's also reducing on cost. We can sweep a larger area with only one mooring, one cable to the grid, and get more energy out. The second part of the low-cost features of our TidalKite system is that the whole system is towable. So we can deploy the kite and the power takeoff by towing with small vessels, multicat type vessels, to keep marine operations cost low. We can do all the maintenance in the workshop at land, and that will make sure that we have a high uptime. Also, we can swap units. So if we have a park of 20 units at sea, we can build 21 units and exchange the TidalKite system to keep the uptime up. This is what I just tried to explain, but then visualized. We call it 3D harnessing. So the kite has a much larger swept area, as well as it operates different planes behind each other to extract more energy. SeaQurrent as a company exists for about 10 years now. We just had our 10-year annual festivities at the end of last year, and we've come quite a long way, of course. After the concept was defined, we tested in a lab environment, our TRL 4 phase, and then we went out to sea. The downside of a kite, if you like, is that testing in a laboratory is quite complex because of the movements of a kite. So we tested scale models at TRL 5, 2 types, from a moored barge in the Dutch Waddenzee where there's flow channels. And now that's our TRL 6 phase we're currently running. We have a half-scale model with a power takeoff and also a mooring. You see the small picture at the bottom. That is the Dutch island of Ameland in the north of the Netherlands, where we have the mooring in place and a grid connection. So there we're going to deliver electricity to this island at the end of the year. In parallel, of course, activities are ongoing to prepare the next model. If you look carefully, you will see that the kite we build now has 6 wings, and the model I have here, which is the future model, will have 10 wings. So part of the scaling up is adding number of wing rows, which we don't need for testing and tuning. Actually, it only makes our life more difficult if we add a lot of wings. But once we can steer 6 wings, we will be able to steer 10 wings and get the commercial model, the TRL 7 model, from the drawing board into reality in the next 2 years. And after that, of course, we're willing and able and active in supporting exploitation projects to deliver continuous renewable energy to the European grids, targeting France, UK, Ireland, and the Benelux at first. So some of the benefits were already elaborated upon, but we're very grateful for some of the first generation technologies, and we see some variants also with Magallanes present here and Orbital, taking on board also some of the features we have and learning from the first generation of tidal technologies that have their pros and cons, and for us it's key to incorporate those learnings and translate into something that works better, 1, and 2, something that complements. So we see ourselves also really as a complement of existing technologies, enabling deployment at more devices, more locations. Because at the end of the day, if you look at the location, the depth will determine how big a device can you deploy, and the water speed is the other important factor. The water speed times the area covered is basically the amount of energy you can extract from a certain site. So that's where our device is based on. So that's the key feature, because we cannot change the water velocity at a certain site, but we can change how we harvest that. As said, that helps on cost. If you look at the details of the cost structure, you see that OPEX and installation costs are quite substantial, and that's where the marine operation costs are being lowered by being able to deploy with smaller vessels. The second element next to the 3D harnessing is that once we've got the kite under control, we can position it anywhere we like. On many locations, you see that illustrated on the right-hand side. It's maybe a bit small, but you see a difference between the ebb and flood flow and at what depth you find the optimal water velocities. For us, it's very easy to have the kite operate a bit lower for the ebb flow and then a bit higher in the water column for the flood flow, or the other way around. And a similar thing goes for the orientation. Not everywhere the ebb and flood flow are 180-degree aligned. We can easily change the operating angle versus the flow. A small picture of our Ameland test site and the installation of the monopile mooring. This is a UNESCO World Heritage. So there's a lot of work that has been done, of course, on the environmental tie-in. Having obtained the permits there, I think, is a testament to the friendliness of the system and the capability of the system to be deployed in ecologically sensitive areas. We do that under the 3 M's, as I call it. So we try to minimize the footprint by using recyclable products and limited use of critical raw materials. We mitigate the impacts. For instance, we use a biodegradable working fluid in the system, and we keep a safe distance to the seabed. And then we have ample activities to monitor what's going on to better understand the behavior of sea life around our system. So that's shortly about our system and relevant other aspects that are the basis, of course, for projects. Looking at France, like in any other markets, we distinguish 4 main targets. We look at islands that want to become energy independent and 100% renewable. We look at offshore wind farms. With our system also capable to be deployed at lower water velocities, we believe we have a good chance to increase the yield per square kilometer of land, or sea, that these units use, and optimize infrastructure, predominantly the cable. We're interested to work with continuous energy customers. Data centers are an example. They're front runners. They started sourcing corporate power purchase agreement power from wind and solar 15 years back, and they all want to be time matched, supplied by renewable energy by 2030. So they really match their their demand. When do we need the power? With when is it produced? And that's the big challenge we see in energy transition. So in France, of course, the potential is in the Channel region, La Manche, Brittany, Normandy, but we also see towards the north, near Boulogne-sur-Mer, Fécamp, and Calais, we see opportunities. Velocities are slightly lower there. Again, as said, that's what we can also focus on. So we really try to widen the deployment potential, also invite people that are active in that area with renewable energy and seeking opportunities to come over and visit us so we can discuss. By the way, this ability to operate on lower velocities is also recognized by the Ocean Energy SRE, the Strategic Research and Innovation Agenda. So it's not just us who says that. Tidal kites are suited for medium to lower velocity currents. As said, we focus on the Netherlands, France, Ireland, and UK, and really want to develop the first projects together. We want to participate in that. We think it's important to take a stake in that in order to be able to convince everyone, but we cannot do it alone. We don't want to be the expert in the French market, regulation, permits, etc., etc. We want to focus most of our attention on providing the best TidalKite system and work together with maybe some of you to complement that with the additional aspects needed to make projects successful. So what's needed for a TidalKite project? That's very much similar to what's needed for a wind project or a nuclear plant. We need the permits, we need the resource, we need the grid connection, we need someone to take the power, to pay investment, etc., etc. So it's, in a way, it's very innovative, but in a way, of course, it's very much standard what we do. And we just have to tick all these boxes, and we're working hard to do that. And then we can realize projects. Next to all these dimensions, of course, there's the phasing. So the first phase, and that's why we're here and we're eager to discuss with you, is, of course, to build the right consortium, find complementary partners so that we can cover everything needed to make a project successful. Then go to a feasibility phase to make sure that it can be done there, and after detailing it, realizing it, we can benefit from the production of continuous renewable energy. That also has, of course, a higher value than some of the intermittent renewables, importantly to say. So that's the roadmap. As said, we cannot do it alone. Things that can be done, of course, and are being done, in particular in France and also in other areas, is marine spatial planning. Let's make sure that tidal energy gets included in the plans. We see that coastal regions and islands are very open to this, but it's very important to make sure that the zoning plans called Marine Spatial Planning at Sea are recognizing tidal potential and are putting the basic cornerstones in place for future deployments. The wider benefits, I think, are important. Just had a discussion over lunch on how do we make sure we can compete with China. They offer low cost. A local supply chain is vital in true energy sustainability and reliability of energy supply. And the feed-in tariff has been mentioned, at least in the sessions I've been attending several times. So yeah, that's important to enable renewable energy projects. So I said we're looking for complementary partners. We're looking for the right locations. And that will be crucial to realize feasible projects. So that said, I want to conclude my story and open the floor for questions if there are any. Anyone, questions? If you don't want to ask an open question to the audience, feel free to visit us at our Innovation Village booth and ask it privately, then we're happy to answer you. Thank you for your time and your attention.
Mm-hmm.